Excellent. Go ahead, answer it.
And the intermediate value theorem, or IVT, is a set of rules that an interval in a function can follow that guarantees a certain output.
Yeah. Okay. Sure. Yeah.
I wrote everything between point A and B exists if the graph is continuous. Like every value of x between A and B exists. If
Okay,
X and Y
so
and
kind of. You're not wrong, but IVT actually reverses it and says that all y values, so f of A and f of B, everything between them exists. That's the IVT, but what you're saying is not wrong. Everything between A and B also would exist, because if it's continuous,
it exists.
obviously it exists in x and y. But we use this specifically for y because we want to know the outcomes, right? So like the example we used was height. Whose height did I use?
Emilia.
There we go, Amelia's height.
Emilia, she had grown
Oh yeah,
50 centimeters in 3 years.
that's right. All right. Well, anyways, let's continue now. Nicholas, do you know where Jack is? No idea? Okay. All right, so, I forgot to delete them. Hang on. You can't see that yet. Let me delete everything. Because I'm showing you the answer key. I need to get rid of that first. All right, so here we are. So guys, we're going to talk about infinite limits and limits at infinity. We've already done these. They're not new. We're just going to focus on them and kind of like make sure you understand them now. So we've already talked about them. So like I said, it won't be anything scary. All right, in our graphical analysis of limits, we've already seen them, as I just mentioned. Let's consider what's going on in these two particular graphs. All right, both of these graphs are rational expressions, right? Rational graphs. So if I look at down here, the limits at infinity, and then, no, let's do infinite limits first. I put them in that order for a reason. I don't know what it is, but I'm sure I did. So this is basically saying that a limit that results in, or when x goes to a. The symbol that you need to put in there is not, I don't have enough room. Hang on, there's definitely not enough room there. So it results in infinity or negative infinity. Yeah? Great. These ones over here, I'll just write it this time, is a limit where x is approaching infinity or x is approaching negative infinity. These ones here we called end behavior, right? So this had to do with like, what is it doing when we go to the extreme left or the extreme right, okay? That's what that one is. Excellent. So if I look over here, and I want to know the infinite limits, I want to know what is happening when the limit as x approaches 2 from the left and the right. Let's do them at the same time. So 2 is obviously our asymptote here. And from the left, what am I approaching? And from the right? Right. So this one was negative infinity, plunged down, and this one went up, diverged to positive infinity. Next one, let's check about -1 from the left and right. So obviously something weird's probably going on there. Nope, in this case it's not. So -1 is right here. That can't be right. Oh, it's because it's G. I was like, that cannot be right. That cannot be what I wanted. Yeah, it's not. I wanted G over here. So if I look at G, -1 is the asymptote. So from the left, what am I going? From the right. Oh, look how smart we are.
Yay! Well, might be the only thing I know how to do in this class.
That's not true. You know how to do lots. Why are you saying that?
Because we don't understand language.
You guys understand lots.
No. I understand lots.
Do you want to know the truth?
There are tons.
On your calculus clue assignment, most of you got 3s and 4s on the actual, like, how do we do this?
I didn't give
The unfortunate truth is that most of you got 1s and 2s on how to actually write it down. Okay? So we're going to go over it later, but, like, you guys do know what you're doing. Why did you get 1s and 2s on the rest of it? Because you don't know pre-calc. That's the problem. The calculus stuff you did great on. You just didn't write things like limit. Whole bunch you just wrote the answers.
We had to write limit. So,
Yeah. It's okay, I'm going to go over it. The whole point of this first assignment is to teach you that stuff and show you. Anyways, now that's in the video. Immortalized on the video. Okay, so next we're going to talk about the left and right end behavior. Left end behavior is when we go approach negative infinity. Right end behavior when we approach. So let's go up. 2 and 2. So in both cases, we approach 2, which is our horizontal asymptote. That's usually what you're going to approach, right? If you're not approaching that, then you're going to approach infinity or negative infinity. So the next one, for example,
The next one is negative infinity and then infinity.
not quite. So you got them backwards. So here, because we're approaching it like to the right end behavior and then left,
Okay.
the right end behavior is infinity, and the left end behavior is negative infinity. It's going to take longer to get there, but it's going to get there, right? Like this is slowly going down, okay? So we get to infinity and negative infinity. And like I said, those are the only 3 possibilities for end behavior. You approach an asymptote or you diverge. Diverge meaning you go to infinity or negative infinity. There's no other option, okay? And over here, when we did this one, what was these? Why did it go to infinity or negative infinity on these ones? When we approach the number, yeah. It was a vertical asymptote. Yeah, exactly. So basically, limits at infinity, right? Like these ones over here, limits at infinity, they can help us find horizontal asymptotes. Infinite limits, when things go to infinity, those help us figure out the vertical asymptotes. Amazing. You had a question or no? No? Okay.
I was going to ask, what happens if instead of going down like to negative infinity, it stops like instead of having the arrow down, it has like a point at the end, so that wouldn't be an infinite limit.
Yeah, exactly. Because then it wouldn't be, yeah. All right, so as I've already mentioned, a limit at infinity describes the end behavior of a function, right? And so that's what we're going to look at here, is what is the end behaviors. Boys, hey, stop. Okay, this is the right end behavior, left end behavior, right end behavior. How do I know that? Because it's approaching infinity, which is to the right, or negative infinity, which is to the left. All right, so in this case, what I want to do here, well, is really, just, you can think of it almost as like plugging it in. If I had like infinity cubed, you're not actually doing this, but this is how you could kind of think of it to help you get there, right? And so if I look at this, which of these things is going to take over? The positive infinity here or the negative infinity here? Which one would take over? So this is going to approach negative infinity because this is larger than this, right? This is smaller. Yeah, you can. Thanks. Kind of makes sense? So it's like an analytical way of trying to figure that out. Now, careful with it because it is hard to get it perfect because sometimes they're a little closer, but essentially what we're trying to do is like reason or quantify the infinities a little bit, right? Figure out like which is more powerful, which one's taking over. So when I look at my next example here, ultimately what you should think of here is if I'm going to have like minus negative infinity, but regardless, it doesn't matter because it's squared. So you can really just think of this as like infinity squared no matter what. Does the 4 matter? No, not at all. Infinity plus 4 is infinity, right? Like the 4 doesn't matter. Okay? Then here, you're going to end up with another infinity, but this time it's negative infinity. If I have negative infinity, does subtracting 3 matter? No. And then here, I'm going to get negative infinity plus 1. Does that really matter? Nope. So once again, let's leave it out.
Why negative?
Because we're approaching negative infinity. Okay? So then, when I have this, I've got infinity times infinity times infinity times infinity, or times negative infinity. But what happens to those 2 negatives? So I'm going to go to infinity, right? Last example here. I'm going to get 3 minus infinity, so negative infinity, over infinity. What's happening?
Negative.
Okay, remember, this is not actually what's going on, but we can think of it this way. It's all right, let's write it out like that. This is not what's literally happening, but you could almost think of it like this, right? It's not literally happening, but it's at the same time, if I'm approaching infinity and it's the exact same infinity, you can kind of think of it as being it's irrelevant. It's going to cancel itself out. And so I'm going to approach my horizontal asymptote that is -2. Now, what's the pre-calc way that you remembered it? Because honestly, I think that's easier in this case. Power equal, right? Power equal, right? It's x over x. Top heavy, bottom heavy, power equal. You didn't learn that. Yes, exactly. This is rational. So that's power equal. So it would be -2/1, and that's my horizontal asymptote. So in this case, like I would probably just go back to my pre-calc because it's easier. Okay? All right, third example. That one is where we're going to develop our analytical process for how we could try to figure this out. All right. Let's investigate the two functions below, and let's look at them graphically and numerically. Graphically, I mean, we can kind of see what's going on here, right? What do each of the functions have in common, though? Okay? What do they both have? They both have a horizontal asymptote where? At y equals 0. And they both have... What's the other one?
0.
Vertical asymptote.
But the other one, where vertical.
This one's not drawn on there, but at the same time, we know it has one. Because if I plug in 0, 1 divided by 0 doesn't work, right? So they both have those asymptotes, okay? So now we can actually try and figure this out. So we learned the 3 rules. I just told you and reminded you what they were. What were they? To figure out asymptotes? Horizontal ones?
Top heavy, bottom heavy.
Top heavy, bottom heavy, power equal, right? So if it's top heavy, then that meant that what was going on is that it just went off, diverged. It went off to infinity. If they were bottom heavy, where was the asymptote? 0. And if they're power equal, you divide the coefficients. Exactly. Amazing. So what we're going to do here to kind of prove this is we're going to divide every term in both the numerator and the denominator by the highest power of x that appears in the denominator. Now, this is essentially us proving the stuff we learned in pre-calc. So, first of all, this is going to be bottom heavy. So we know where it should be. But now we can prove it using limits. Because what is the first thing I do with a limit? I always plugged it in. If I do that, it's still kind of awkward, right? So instead, what I'm going to do is divide everything like that suggested so that we can see what's happening. So I'm going to get x divided by the greatest power in the bottom, so x squared, plus 2 over x squared. Bear with me on this. I know. X squared over x squared, plus 5x over x squared, plus 6 over x squared. I told you, bear with me.
So what we're doing is that we're dividing by...
We're dividing everything by the greatest degree in the denominator. Okay? When I do that, then I can simplify this. And I'll get the limit as x is approaching infinity of, what's x over x squared? Kind of, 1 over x. Plus, this one I can't do anything to. On the bottom, x squared divided by x squared is 1. 5x over x squared is 5 over x. And 6 over x squared. Okay. What do I do with a limit once I simplify it in whatever way I'm simplifying it? What was the next thing I tried? Plug it in. Exactly. So if I do that, what is 1 over infinity? 0. 1 divided by an infinitely large number gets closer and closer and closer to 0 until it just is 0. Right? Think about it. Let's think of it this way. What's 1 divided by 1? 1 divided by 10. 1 divided by 100. 1 divided by 10,000. 1 divided by 1,000,000. 1 divided by 1,000,000,000,000. And at that point, are we basically like negligible? It's basically 0. Now we're going to go by something bigger. We're going to divide it by infinity. So it's 0. Now, the answer isn't 0, but when we're saying the limit as x approaches infinity, we can definitely say that's equal to 0. Does that make sense? Okay?
You only did 1 over.
I'm not done. I stopped because you all went what?
Oh, it's 2 over.
Okay, so now 2 divided by infinity squared, well, that's clearly 0 if, a number divided by infinity is 0. This is just 1. 5 divided by infinity is 0. 6 divided by infinity squared is 0. So all in all, I got 0 over 1. And so I got 0, which is exactly where this asymptote lies, right? So we've used our calculus to kind of prove, yeah, it's bottom heavy,
But
all right?
can we use our pre-calculus?
Unless I ask you not to. There's times where, remember I said I'm going to do a lot of justification. I'm going to ask you to prove it.
So if we have proofs, we have to do this. If we don't have proofs, we can just say it's
So,
bottom heavy.
We're proving
Amazing.
Mr. Approving here is that us.
Exactly. That's essentially what we're doing. Yeah.
Yes, sir. Sir, is that on the first step when you divided x by x squared? I didn't catch. How did you change it?
No,
Like,
yo
how
no
did that divided x squared to the way you wrote
Parecía
it?
que era demasiado.
Do you understand the question?
I have no idea what you're asking. Look, I'll do it again here and see if it makes sense, okay? I'm going to take this, and I'm going to write the limit as x is approaching infinity. I'm going to divide everything on the top and bottom by the greatest degree in the bottom, which is x squared. So, 2x squared over x squared plus 7x over x squared plus 6 over x squared all over x squared over x squared, 5x over x squared, 6 over x squared. I can simplify some of that.
It's over X.
The first one is 2.
Don't take
So the limit as x approaches infinity of 2 plus 7 over x plus 6 over x squared over 1 plus 5 over x plus 6 over x squared. And really you're starting to get the idea, I'm hoping, because now what happens to everything that has an x?
Everything that over x is 0.
X squared doesn't cancel.
The what?
The 6 over X.
Well, it will once I plug in infinity. It doesn't yet. Because now when I plug in infinity, I'm going to get 2 plus 0 plus 0 over 1 plus 0 plus 0, or just 2. And guess what? That's where it lives. And remember, this is like power equal. If I look at the power equal, pre-calc told us to divide these two things. What do I get? 2. So I get the same thing, right? Because this is the same.
You can do it both ways.
Yes, but what I told you is that if you have to prove it, this is how you're going to prove it. Me too. Let's take a nap.
Mr. Brown, let's go on nature. Yes.
I wish. All right. So now this one here is top heavy. And I'm going to do the limit as x approaches infinity of x squared over x, 3x over x, 2 over x, all over x minus 1 over x.
It's only because X is in the second.
Yep. X squared over x is x plus 3 plus 2 over x. X over x is 1 minus 1 over x. And at that point, then I plug in my infinity, and I'm going to get infinity plus 3 plus 0 over 1 minus 0, which is really infinity, right? Adding 3 to infinity doesn't matter. So this is really just infinite. And of course, if I look, I can see that's exactly what's going on, right? If I go to the extreme right, it is doing that. And so, of course, this was our top heavy. So again, yes, this is pre-calc. We can use bottom heavy, top heavy, power equal, but this is how we can prove what's going on. Why do we what?
Porque es infinity más 3.
Yeah. And if you have an infinitely large number, adding 3 to it doesn't matter.
Yes, sir.
Yeah.
Why on that last problem you chose to divide by x equals supposed to be top heavy x squared.
because I'm always dividing by whatever the degree is on the bottom. All right. Let's see what's going to happen if we do the same thing, but this time we approach negative infinity instead. Okay? So I'm going to do it again. I'm going to get the limit as x approaches negative infinity now. I'm going to go straight to this because we've already done this one, so I'm going to simplify it for you, okay? So remember, we're dividing everything by x squared, and let's do the simplification while we're at it. Boys, you either don't understand and you need to ask a question, or you're talking too much and you need to stop. Okay? All right. I'm going straight to this because you guys should already know how to do it, right? Because we just did this one, literally. So I'm just dividing everything by x squared, and I'm doing the simplification at the same time so we can write out less steps. Then I'm going to plug it in, and I'm going to get 2 minus 0, right? Because if this is negative infinity, it's like minus 0, I guess. Negative infinity squared is going to be plus 0 over 1 minus 0 plus 0. Does it matter if I add or subtract 0? Makes no difference whatsoever. So the answer is still 2, right? It doesn't change the answer at all. Nope. Not always. Because now let's look at the next one. So now, as x is approaching negative infinity here, I'm going to, remember I'm dividing everything by x. So I'm going to say x plus 3 plus 2 over x over 1 minus 1 over x. So all I did is divide everything by the degree on the denominator and then simplify it so I've, don't have to write out 2 steps. Last time I was plugging in infinity. This time I'm plugging in negative infinity. So I got negative infinity plus 3 plus, or minus 0, technically, over 1 plus 0, which is really just negative infinity, which we have the graph. We can confer, or we can check, I guess, that that's exactly what's going on, right? We're plunging down to negative infinity. Yeah? Wow. Silence. Nobody's sure.
But this isn't too bad.
Good.
I think what we were doing in that is not worse. I'm like falling asleep.
Me too. Me too. I guess we could turn on the lights.
No, I like how.
We don't want to give you a seizure. All right. So based on what we just saw, right? What does approaching negative infinity make a difference to the result of our limits? Well, it makes a difference only in one of the 2 cases. So
Only if it's.
if it had an oblique asymptote, basically. So if the function has a horizontal asymptote, then the end behavior didn't change. But if the function has an oblique asymptote, then it could change the sign. Based on what we just saw, right? Like those are the 2 observations we just saw. Okay. Suppose the following limits were given you in multiple choice. What would the result of each limit be? Base your reasoning on the intuitive understanding from the graphs above. Yes. Yeah, I just mean slanted. Yeah, oblique means slanted. All right, well, let's take a look at this next one. This one here, right, should be negative 2/3 when we plug it all in, right? Because the x squared over x squareds are going to cancel. That's what we should get. To prove it, if this is divided by x squared, it's going to be 0. Negative 2x divided by infinity is going to be 0. And then minus 2, and the x squareds will cancel. Over, on this one here, I'm going to get 3, because the x squareds cancel, plus 0, minus 0, right? Because if these are divided by an infinity, they're going to go away. They don't matter. So all that's left is our negative 2/3. Yeah? Next one. If we do the same thing here, right? This one was top heavy, so we're going to assume that this one should go where?
Infinity or negative infinity. That one will go to negative infinity.
We're going to think it goes to negative infinity. So let's check it out. So in this particular case, we're going to get 2x minus 1 plus 5 over x. Because x over x. Yeah, x over x. And so we get that, yeah?
So this is 0.
Remember, this is the one that had the oblique asymptote. Wait, was it?
Yes.
Yes, it was. Well, it's a different one, but it is still one. It still has an oblique asymptote. I just thought it was the same one, but it is different. So when I do this, I'm going to get negative 2 infinity minus 1 plus 0 over 0 minus 1.
It's not minus 0.
It technically is minus 0, yeah. I mean, again, we discussed last time, it doesn't matter if it's positive or negative, so that's why I just kind of wrote it as positive each time. All right, so here, does the 1 matter? Like the minus 1? No. So it's really negative 2 infinity over negative 1. Does the 2 matter? Not really. And so the negatives do matter. It actually went to positive infinity. And remember, we had just said it could change the sign.
Why did it put infinity negative? It says
No, porque los signos se cancelan.
I didn't. I put the negative here. I always, guys, if you write this, I can guarantee you that one of you is going to think that that's 2 minus infinity, and that's not what that is. Even if you write it this way, you're still going to, somebody's going to go, oh, 2 minus infinity, and that's not what it is. Always move the negatives to the front, okay? Otherwise, you're more likely to make a mistake. All right. We're killing Amelia today. Everybody, I know, I'm really tired. I feel like it's Friday afternoon, not Tuesday afternoon.
We should joke about it.
All right.
Tomorrow's going to be a good day.
Let's take a look at this graph, though. What do you notice that's different about it? Okay, there's a curve, sure. Julieta, what else do you notice about this graph?
Horizontal asymptotes.
There's 2 horizontal asymptotes.
I did that proper observation, didn't I?
You did. You did.
And you tried to...
Miss, I don't know anything.
No, I told you I know how to read graphs, and that's it.
So then, what is the end behavior, or the limit, as I go to the negative infinity? What am I approaching? And what about from the right? Or the right side, sorry.
The right side goes up to 2.
Goes to 2. Right? So essentially here, if we have 2 different horizontal asymptotes, we need to check which one it's going to, because it could go to either one. Right? Now, obviously I can take these and I can actually prove that, so that's what we're going to do in this next one. We're going to algebraically do that, rather than having the graph. Because we don't always have a graph. So here's what I want you to think of. The square root of x squared is equal to x if x is bigger than 0. Over here, the square root of x squared is equal to negative x, sorry, if x is less than 0. I want you to think about that for a minute and see if it makes sense to you.
Yes.
Because technically what's happening here with like the square root and the squared? They're effectively canceling. So if x started as negative, it's going to be negative. And if it started positive, it's going to be positive. That's all we're saying here. That's the statement. Okay? So then let's actually do what we did before. So the limit as x approaches infinity. And if I'm dividing by the square root of x squared, in this case, I'm dividing by x or negative x for this one. X, right? And the key here is, I know somebody's going to try and divide by x squared, but it's not x squared because it's rooted on the bottom. So that's the reason that we're going to switch this and say that no, we're dividing by x everywhere.
But why did we get rid of the 2 and the 1? Ah, no, we didn't.
We did not. Now when I put it back under the root, it's x squared again.
Why?
Right? Because when I pull out the x squared under the square root, it's an x, like we just wrote up here. But down here, this part is under the square root, so I have to divide by x squared, the original thing that's there. Okay? Then I can simplify this all.
And just let's square it up.
This is going to be the limit as x approaches infinity of 2 minus 2 over x over the square root of 1 plus 1 over x squared. Then I plug in my infinity. I'm really going to get 2 minus 0 over the square root of 1 plus 0, which is really just 2. Yeah? No? Maybe? This is the one that we just did up here with the graph, right? So it should have been 2. This next one is where now we're going to say that we're approaching negative infinity. We should get negative 2 for this one. Now, we already did the simplification. It's the exact same question, except that this time we're dividing it by negative x. So this one, it's going to be 2x over negative x minus 2 over negative x all over the square root of x squared over x squared plus 1 over x squared. Notice this time I don't make it negative. Why? Because it's squared. It's always positive, right? If I square something that's negative.
So,
Yep.
Can you explain again, please, that I didn't understand why this time we divided by negative x?
This part right here. The square root of x squared, if x started negative, is negative x. Right? Then I can simplify this. This is going to be negative 2 plus 2 over x all over 1 plus 1 over x squared. And that's still the limit as x is approaching negative infinity. Which is really, like now that we plug it in, it's going to be negative 2 plus 0 over the square root of 1 plus 0, which is now negative 2. And so we can see that, yes, algebraically we proved it went to the other asymptote when we went to the left. Confirm our results, we just did. You guys can glance up. But if we glance up, on the left, we went to the negative 2, and on the right-hand side, we went to positive 2. So let's try another example. This time, there is no graph. Because now we know it works.
This is where you lose me.
No. Look at this. Remember, the square root of x squared equals negative x if x started negative. In this case, it did. So I'm going to go ahead and take this. I'm going to go 3x over negative x minus 2 over negative x all over square root of 2x squared over x squared plus 1 over x squared. This is all the limit as x approaches negative infinity.
So you're going
Super
super
fast?
Yeah,
Nobody can play. Like
do
you
you
have
drink a lot of coffee?
just
No, I don't drink any coffee.
Do you not drink like any coffee?
Tea.
that has tea in it.
No, but I drink tea, but I don't drink like gross like tea.
Okay.
I drink matcha.
I don't either, but here I do because I
You know
have
what
to.
is saying?
It's easier. Anyways, now I can simplify this. This would be like negative 3 plus 2 over x over the square root of 2, because the x squareds cancel, plus 1 over x squared. This is still the limit as x approaches negative infinity. Then I plug in my negative infinity, and this will be negative 3 plus 0 over the square root of 2 plus 0, which is
0.
negative 3 over root 2.
It's in
Or
ingredients.
possibly because, Americans, well, let's write it vertically, actually. Negative 3. Yes. Negative 3 square root 2 over 2 if you're more American. So for instance, on the AP exam, guys, you're going to see that. The rest of the world does it sometimes. The Americans always do it. They hate square roots on the bottom.
In the other way.
I'm going to wait. I'm literally in the middle of teaching.
You haven't rated it.
Can we do it the other way? Like, not with the one.
What?
Can we leave it like the first way?
Yeah.
But like the exam they mark it wrong.
If you write, are you writing the AP exam? Then I would rationalize. But for me, yes, Pertuse.
The other one, it's be negative.
Huh? In this one?
In the other one.
No. So let's do it together because it's not.
But it would be negative x. Okay.
Yes, I see what you're saying. Yes. In this case, once again, the square root of x squared is going to be negative x because x started out negative. Yes, now I understand your question. Great. Okay. So, if we do this, we're dividing by negative x again. So x squared over negative x plus 2x over negative x all over the square root of 3x squared over x squared plus 2 over x squared. I'm just going to do it this way this time because I'm tired of writing limit. Okay. This is going to simplify to negative x minus 2, my bad, over the square root of 3 plus 2 over x squared. Then I'm going to plug in my limit, right, because this is the limit as x approaches negative infinity. If I do that, I'm going to get infinity minus 2 over the square root of 3 plus 0, which really the things that matter then
Why infinity positive?
are just going to be infinity. Because it's negative infinity. Right? We're plugging in negative infinity to a negative value.
Sir, can you put it? No.
All right. But any questions about that? Yeah, what's your question? No, because then you can't see the answer.